Dear students, in this lecture and the upcoming lectures, we will discuss the concepts of trigonometry. All the definitions and the observations that we'll discuss in today's lecture will help you to understand trigonometry in much simple and easier way. After understanding the basics, we will solve a number of problems to just get a good hold over the whole concept. Alright, so without wasting any time, let's start with the lecture. Now the concept of trigonometry is based on a right angle triangle, particularly if we talk about 10th class trigonometry. Now let us take a triangle ABC, right angled at B, and the base angle as angle A, which I have marked as angle theta in the diagram. So the important thing to understand and to keep in mind while understanding the concept of trigonometry is that which side is considered as hypotenuse, which side is considered as perpendicular, and which side is considered as the base of the triangle. Now we know that side opposite to 90 degree for every right angle triangle is always a hypotenuse, and the side opposite to angle theta under consideration. Now my base angle over here is A, which I have taken theta as mentioned earlier. Now this angle has a side opposite to it marked as BC, which we will consider as perpendicular of the triangle, and the side which is in contact with both 90 degree and theta is considered to be the base of the triangle. Okay, so three important things to observe and understand before moving on with the next part of the concept or the topic is that side opposite to 90 degree angle is hypotenuse, side opposite to base angle or angle under consideration theta is perpendicular, and the side which is in contact with 90 degree and the angle theta is considered to be the base of the triangle. So this is my base, this is hypotenuse, and this is perpendicular. Okay, so once we know this concept, we can further move on to define the different trigonometric ratios. We can define different ratios using the sides of this right angle triangle. Now, my first trigonometric ratio is sine theta, which is the ratio of perpendicular and hypotenuse. So when we talk about, say, we want to find the ratio of different sides, one of the ratio can be perpendicular upon height. Now we term or we name this ratio as sine theta. We can take another ratio which is, say, base upon hypotenuse, and we name this ratio as cos theta, and then we can also take the ratio as perpendicular upon base, and we name this ratio as tan theta. So far we have defined three different ratios: sine theta, which is perpendicular upon hypotenuse, then it is cos theta, which is base upon hypotenuse, tan theta, which is perpendicular upon base. There is a phrase which will help us to remember this whole set of three ratios, that is, some people have curly brown hair through proper brushing. Now we take s from sum and define it as sine theta. This is equals to perpendicular upon hypotenuse, that is p by h. Similarly, curly से c pick किया आपने, so cos theta is equals to base upon hypotenuse, p upon h, through tan theta, that is equals to perpendicular upon base. Alright, so three different ratios and a trick to remember the name or the ratios in which we have defined them. Now if we talk about the ratio of p by h, we can also define the ratio as h by p. So I can say that similarly we have three more ratios which are the reciprocal of ratios as h by p. Now h by p is termed as cosecant theta, h by b is termed as secant theta or sec theta, and b by p is termed as cot theta. So cosecant theta, secant theta, and cot theta are three different ratios which are obtained by taking the reciprocals of sine theta, cos theta, and tan theta. Alright, so far we can say that there are in total 6 different trigonometric ratios depending upon the ratio of different sides which we can take into account. Now, based on the theory that we have discussed so far, there are some important observations which we must remember in order to understand the concept in more depth. Alright, so if we talk about sine theta over here, हमने sine theta को define किया है. Sine theta is perpendicular upon hypotenuse, and cosecant theta is nothing but hypotenuse upon perpendicular. So based on these two, we can say that the right hand side suggests that sine theta and cosecant theta are reciprocal of each other. So this is my first observation, that sine theta is equals to 1 by cosecant theta. Or I can say that cosecant theta is equals to 1 by sine theta, one and the same thing, or vice versa. Similarly, cos theta we have defined as base upon hypotenuse. Okay, so you remember the phrase sine theta. Some people have curly brown hair through proper brushing. So this is what I have. So I have three different ratios. Now if I take a reciprocal of the ratio as h by p, we define this thing as sec theta or secant theta. Similarly, b by p is termed as cot, or complete name is cotangent theta. So six different ratios. Now from the second part, cos theta is b by h and secant theta is h by p. Both are reciprocal each other, and therefore my second observation is that cos theta is equal to 1 by secant theta, or secant theta is equals to 1 by cos theta. Similarly, tan theta is, since it is p by b and cot theta is b by b, that gives me my third observation, which says that tan theta equals to 1 by cot theta and cot theta equals to 1 by tan theta. Now first three observations are quite obvious, which we can easily observe by just looking at the ratio in different forms. About fourth and fifth observation, what we are going to do, we are cos theta is b upon h. Now if I take the ratios, h and h are going to cancel out and I am left with p by b. What is p by b? We can observe that perpendicular upon base is nothing but tan theta. So this is sine theta upon cos theta is nothing but tangent or tan theta. So I can write it like this, that tan theta is nothing but the ratio of sine theta upon cos theta. Similarly, if I take the ratio other way around, I take cos theta in the numerator and sine theta in the denominator, it is going to be b upon h upon p by h. So once again h and h will cancel out and you are left with b upon p, which is nothing but the last ratio, that is cot theta. So we can finally write this thing also as cot theta equals to cos theta upon sine theta. So this is the theory for the first part of the chapter. We have divided this whole chapter into four different parts. This is the very first part where we are only defining the trigonometric ratios as the ratio of sides of a right angle triangle, that is in terms of perpendicular, base and hypotenuse. Now let us take few questions based on this one, but before this I want you to revise and remember all of these ratios which we have defined, as well as the observations which we have studied so far using the whole concept. So write down each and every observation, the diagram, and mark the angle theta and the vertices a, b and c, so that you can have the whole concept properly written in your notebooks. Moving on, we'll take few questions based on this whole concept and the theory part that we have discussed so far. So let us take our first question. As we discussed that everything in the triangles or in the trigonometry is discussed or is explained with the help of perpendicular, base and hypotenuse, especially when we talk about the 10th standard trigonometry. Okay, so our first question is that in triangle ABC, which is right angled at B, AB is equals to 24 centimeter, BC is equals to 7 centimeter, and determine the value of sine A and cos A in the first part and sine C and cos A in the second part of the question. Okay, so suppose I want to find the values of sine A and cos A. It means my angle under consideration is A. So in the diagram we'll draw or we'll keep the base angle as A and will accordingly manage the other vertices of the triangle. So if my base angle is A, since it is given that the triangle is right angled at B, so my angle B is 90 degrees, so third vertex is going to be C, obviously. Alright. Now values are given specifically that AB is equals to 24 centimeter and BC is going to be 7 centimeters. So my perpendicular is BC over here because that is the side opposite to angle A. AB is 24, which is going to be the base of the triangle, as it is in contact with the two angles 90 degree as well as angle A over here, and the side opposite to 90 degree is going to be your hypotenuse, right? So in this case, if the sides are given to me, I can simply use Pythagoras theorem in a right angle triangle. We already know that in case of a right angle triangle, Pythagoras theorem helps us to find the value of the third unknown side if two of the sides are known to us. Alright, So I have explained the whole question in detail over here, but I want you to solve this question on your own and then match your answer as I have written over here. So let us start the discussion. You can pause this video, work on the solution, and then recheck your solution as discussed over here. Alright, so remember, practice is something that you have to do on your own. No one can replace that thing. So you must be ready with the practice part. Now, in order to find sin A and cos A, my first objective is to find the value of the third side of the triangle ABC. The third unknown side is the hypotenuse. And we know that h square is equals to p square plus b square. So using Pythagoras theorem over here, I'm going to substitute the values which are already known to me. What I know the value of perpendicular, that is p, which is 7 centimeter. I know the value of base of the triangle, which is 24 centimeters. So substituting the value of p and b, I have h square equals to 7 square plus 24 square. You know that 7 square is 49 and 24 square is 576. So h square in on all, that is equals to 625. I know that 625 is a perfect square. Which number is the one whose square is 625? It is 25. So h is 25 centimeters. So using Pythagoras theorem, we obtained the third side of the triangle, which is 24 centimeter. Now let us try to find the value of sin A and cos A. What is sin A? Now some people have sin A means sin A is equals to perpendicular upon hypotenuse. It is the ratio of perpendicular and hypotenuse, and according to the triangle, if you observe, perpendicular is 7 centimeter and hypotenuse, which you have obtained in the above expression, h is 25. So this gives me sin A equals to 7 upon 25. Similarly, cos A is given as base upon hypotenuse, curly brown here. So cos A is equal to 24 upon 25. It is again the ratio of base and hypotenuse. So just substitute the values, and that is going to be the answer to the first part of the question. Alright, so that completes our first part. Now moving on with the second part of the question. Here I need to find the value of sin C and cos C. So what I'm going to do, I'm going to once again draw a new triangle in which the base angle is going to be C. Since the triangle is already given that it is right angled at B, so B is fixed. So therefore A vertex will be at the top of the triangle. Okay, so now base angle is C, B angle is 90 degree, and obviously the third remaining vertex is angle A. What do we have now over here? So BC base is 7 centimeter, that is given to us. AB is 24, that is given to us. So we are accordingly marking the values, AB as 24 and BC as 7 centimeters. So let us look at the two diagrams simultaneously. Since the side lengths are fixed, so if AB is perpendicular in the second diagram, which was base in the first diagram, but according to the given conditions, still AB is 24. So in this case, perpendicular or P is 24. BC was 7 centimeter in the previous case. Again, BC is now the base of the triangle, so length remains same. BC is 7 centimeter. Hypotenuse आपने evaluate किया था, that was 25 centimeter. So again, we are directly going to use this thing. Now cos C and sin C is what you need to evaluate. First of all, if I want sin C, this is equals to perpendicular upon hypotenuse. Now pause for a moment and observe that in the triangle corresponding to this second part, perpendicular is AB, alright, and hypotenuse is AC, which is same as the previous one. So what is going to be the value of sin C? It is perpendicular upon hypotenuse, that is 24 upon 25. And cos C, which is base upon hypotenuse. Now base is 7 in this case and hypotenuse is 25, so it is going to be 7 upon 25. Now the two parts of this question that really helps you to understand the concept of base angle, how to apply it while solving the question. When the base angle, when we need the value of sin A and cos A, I will take the base angle as A. When I need the value of sin C and cos C, I'll take the base angle as C, and accordingly I'll write the values of the two sides. So since according to question, AB is 24 and BC is 7, so throughout the two parts, AB and BC will remain same, and hypotenuse, as we calculated earlier, it is 25 centimeter. So this is how we obtained the first question. Now properly analyze the question and the whole theory behind it, whether you are able to understand the whole concept. If you are not, just pause for a moment or once again review the video so that you can understand the whole concept properly. Now let us take the second question of this lecture. Every question over here that we are going to discuss is based on the concept of trigonometric ratios. Let's once again revise. Sine theta is perpendicular upon hypotenuse, cos theta is base upon hypotenuse, tan theta is perpendicular upon base, cosecant theta is hypotenuse upon perpendicular, secant or sec theta is hypotenuse upon base, and cot theta is base upon perpendicular. You can write the 6 ratios on a piece of paper or in your notebook and try to analyze or observe multiple times so that you can remember the values, or you can always run the phrase "some people have curly brown hair" through proper brushing in your mind to just keep in mind the values and their ratios. Now for the second question, in the given figure we are given that PQ is 12 centimeter or 12 units, PR is 13 units. Now find the value of tan P and tan and cot R. Alright, so I need the value of tan P and cot R, and eventually I want to find out tan P minus cot R. So first thing first, what we need to do, for every right angle triangle you need to find the value of the unknown side. What is the unknown side? QR is the unknown side over here. So use Pythagoras theorem over here to find the value of the side QR. I know that according to Pythagoras theorem we have PR square equals to PQ square plus QR square, that is H square equals to P, or H square equals to P square plus B square. Okay, so this is your Pythagoras theorem. Substitute the values. H is PR over here, which is 13 square, equals to PQ, which is 12 square, and plus QR square. So simplify the whole expression. QR square equals to 169 minus 144, which is 25. That gives me that QR is equals to 5 centimeter. Okay, so first part of the question was to find the value of the unknown side, that is QR. So once we know the value of QR, we can further use it to find the value of tan P as well as cot R. First of all, let us find the value of cot R, since we have already taken base angle as R. Now what is cot R in terms of the ratios? Cot R is base upon perpendicular, that is QR upon PQ. What is QR? QR is 5 centimeter that we have obtained using Pythagoras theorem. So let us mark this sign as 5, and perpendicular is 12, which was already given to you. So cot R is nothing but 5 upon 12. Now if I want to find the value of tan P, either you can observe that if P is the angle, then QR will act as the perpendicular and PQ will act as the base, or you can draw the triangle once again as I have given in the question. So in the new triangle I have taken P as the base angle. Why? Because I want to find the value of tan P. It means my base angle is now P. So in this triangle, Q remains same because it is 90-degree angle. P and R are going to interchange their positions. So P comes as the base angle and R goes at the vertical angle. Now, if I want to find the value of tan P, in this case it is going to be perpendicular upon base. Now, what is perpendicular? Perpendicular is QR, which is 5 centimeter as we obtained it, or we calculated it and using Pythagoras theorem. PQ is given to you, which is 12 centimeter or 12 units. So what is the value of tan P? It is perpendicular upon base, that is 5 upon 12. Now tan P and cot R, once we have these values, what we need to evaluate? I got these two values, but I want to find the value of tan P minus cot R. So just substitute these values. You can see that both the values are same. It is 5 by 12 and minus 5 by 12. So eventually my answer is 0 over here. Alright, so once again, take a pause, understand the question, review what is given in the question and what is the expression that you want to evaluate. In that expression, I need to find the value of tan P minus cot of R. So using two different triangles, for tan P take base angle as P, and for cot R take base angle as R, and find their value and then find the difference of those two. Now let us take the next question over here. For this question, it is given that if sine A is equals to 3 by 4, the ratio of is given as 3 by 4. Now we need to find the value of cos of A and tan of A. Alright, now sine A, I'm not going to draw the triangle since we need to find the value of cos A and tan A. Same angle is there, we are not changing the angle. So you can draw the triangle, right angle triangle, but the base angle should be A, and perpendicular or 90-degree angle can be anything. You can take it as B or you can take it as C. So even without drawing the right angle triangle, you can solve this question. But you must know what is sine of A equals to. Sine of A equals to 3 by 4, but actually sine A is defined as perpendicular upon hypotenuse. Alright, so I can assume that p is equals to 3 and hypotenuse h is equals to 4. Now these are not the exact values because we are talking about the ratio over here. So I can say that p is equals to 3k and h is equals to 4k as we apply the concept of ratios. Alright, so we can take it as p equals to 3k and h is equals to 4k. But since I need to find the value of cos A and tan A, which are itself the ratios, so even if I skip the k part, I can still get the same answer because eventually we need to find the ratio of the sides. Alright, so moving on with the solution part, comparing p by h with 3 by 4, we can take p equal to 3 and h equal to 4 units. Again, what is not known to us? The base of the triangle. For base, which theorem we are going to use? We are going to use Pythagoras theorem. So according to Pythagoras theorem, as we all know that h square equals to p square plus b square. Substitute the value of h as 4, which is 4 square equals to 3 square plus b square. So you will get b square equals to 7 and therefore b is equals to root of 7. So this is the value of the base. Alright, so we got the value of base of the triangle. Now what we need to evaluate, we need to find the value of cos of A. Cos of A आपके पास क्या ratio है? Cos A is nothing but base upon hypotenuse. What is base? Root 7 and hypotenuse is 4. And you also need to find the value of tan of A. So tan of A is perpendicular upon base and this is equals to 3 by root 7. Again, understand the concept, take a pause, understand the whole question, how we have solved this question, that is important thing. So in the previous 3 questions, the only thing that you need to start with is to take into account the ratios which are given to you and find the value of the third side which is unknown to you. So if I know the value of p and b, I will find the value of h. If I know the value of h and p, I'll find the value of p. If I know the value of h and b, I'll find the value of p. So the third side is to be calculated first and then you can find any trigonometric ratio depending upon the base angle. Okay, moving on to the fourth question. What do we have? Question is, given that 15 cot A equals to 8, find sin A and secant A. Alright, so we are talking about this is our first lecture on trigonometry and we have to find the values of different trigonometric ratios given one of the trigonometric ratio. So 15 cot A is equals to 8, that is given to you. That means it can be rewritten as cot of A equals to 8 upon 15. So this ratio is 8 by 15. What is cot A? Cot A is the ratio of base upon perpendicular. It means I can compare and we can take base equals to 8 and perpendicular equals to 15. So this we can take by just comparing the ratios. It means which side is not known to us? Hypotenuse is not known to us. How to calculate hypotenuse? Using Pythagoras theorem. So apply Pythagoras theorem, h square equals to p square plus b square. Substitute the value of p and b. So 15 square plus 8 square, that is going to be 289. So h square is 289, that is going to give me h as 17. Alright, 17 square is 289. So hypotenuse is 17 for this triangle. It means now what I need to find out? I need to find the value of sin of A. Some people have. So sin A is equals to perpendicular upon hypotenuse. Perpendicular is 15 and hypotenuse is 17. So just substitute the values of these two lengths and these two sides and that will help you to find the value of sin A. Similarly, second thing that you need to evaluate is secant A. How to evaluate secant A? Secant A is hypotenuse upon base. Alright, hypotenuse is 17, base is 8. So my answer is 17 upon 8. So that is how we are going to calculate the values of these two ratios. So I hope by now you are comfortable in finding the values of different trigonometric ratios when one of the trigonometric ratio is given to you. Given that secant theta equals to 13 upon 12, find the values of all other trigonometric ratios. It means one of the ratios is given to us and we need to find the value or the values of all the other 5 trigonometric ratios. Now let us apply the same concept. If you know how to find and use the value of secant theta to find the value of other unknown side of the triangle, we can easily manage to find the values of all the other trigonometric ratios. Let us start with the given condition. So secant theta is 13 upon 12 and we know that secant theta is reciprocal of cos theta. So it is hypotenuse upon base. H is 13 and base is 12. Alright, so h square equals to p square plus b square. This is what we are going to use. Pythagoras theorem. Substitute the value of h as 13. So 13 square equals to p square plus b square, that is 12 square. So while solving the questions, always use the Pythagoras theorem in the straightway form. Just substitute the values and then try to rearrange the terms. So I have 169 equals to p square plus 144. That is going to give me p square equals to 169 minus 144. That is p square is 25 and therefore p is equals to 5 units. Now using Pythagoras we obtained the value of p as 5. Now what I need, last step is to find the values of all the other ratios. Sin theta is perpendicular upon hypotenuse. Perpendicular is 5, hypotenuse is 13, so the ratio is 5 by 13. Cos theta is base upon hypotenuse, that means 12 upon 13. Tan theta is perpendicular upon base, which means 5 upon 12. And cosecant theta can be written as hypotenuse upon perpendicular, but I have written it as reciprocal of sine so that you can remember these observations and properties about secant and cosecant and tangent and cotangent and something like that. Alright, so cosecant theta is the reciprocal of sine, which means if sine theta is 5 by 13, then cosecant theta is going to be 13 upon 5, the reciprocal of this thing. Or you can use the other method also, that cosecant theta is h upon p, that is up to you. Similarly, cot theta is reciprocal of tan theta, that means it is 1 by tan theta. So if tan theta is 5 by 12, cot theta is going to be 12 upon 5. Alright, or you can use that cot theta is base upon perpendicular to find its value. Alright, so it's up to you which method you want to follow from the theory that we have studied so far. Our main objective is to find the values of the n. Alright, now let us apply the whole concept that we have studied to find the values of given expressions. In the given question, if cot theta is equals to 7 by 8, find the value of 1 minus sin theta into 1 plus sin theta whole upon 1 minus cos theta into 1 plus cos theta. And second part is to find the value of cot square theta. So apply the same trick and the method. Cot theta equals to 7 upon 8. What is cos theta? Cot theta is base upon perpendicular. So comparing the two expressions, b is equals to 7 and p is equals to 8. What else do I need? I need the hypotenuse of the triangle. So h square equals to p square plus p square. Again using Pythagoras theorem, find the value of h square and then h. So what is h square equals to? It is 8 square plus 7 square. That means h square equals to 64 plus 49 and that means 113. So h is going to be root of 113. Alright. What I need? I need to use the values of sin theta and cos theta to find the value of given expression in the first part. So sin theta is perpendicular upon hypotenuse, which means it is 8 upon root 113, and cos theta is equals to base upon hypotenuse, that means it is equals to 7 upon root of 13. Now let us put these values in the given expression. First of all, I need to find the value of 1 minus sin theta into 1 plus sin theta upon 1 minus cos theta into 1 plus cos theta, which can be written as using the identity a square minus b square. So I have 1 minus sin square theta or 1 minus sin theta whole square, one and the same thing, whole upon 1 minus cos theta whole square. Substitute the value of sin theta. We calculated that sin theta is 8 by root 113. So 1 minus 8 by root 113 whole square upon 1 minus 7 upon 113 whole square. Take the square of these expressions. We are going to get 1 minus 64 upon 113 whole upon 1 minus 49 upon 113. You know how to solve this thing? Take LCM. It will be 113 minus 64 upon 113 and 113 minus 49 whole upon 113. The denominators of the both numerator and denominator will cancel out and you are just left with 49 upon 64 as the value of this whole expression. Alright, so that gives me the answer to the first part of the question. Next I want to find the value of cot square theta. Now cot square theta is nothing but cot theta whole square. And what is cot theta? Cot theta is nothing but base upon perpendicular. Okay, base is 7, perpendicular is 8, so it means it is nothing but 7 upon 8 whole square, which is 49 upon 364, and that is the answer to the second part of this question. Okay, so far we have discussed 6 questions based on the same concept that we have studied in the beginning, that is 6 different trigonometric ratios defined in terms of perpendicular, base and hypotenuse. So if 3 cot A is equals to 4, check whether 1 minus tan square A upon 1 plus tan square A is equals to cos square A minus sin square A or not. So it means we need to verify whether the two expressions are equal to each other. Let us start with the same method. So here we have cot of A. There's one slight mistake over here. This is cot of A equals to 4 by 3. Now cot of A equals to 4 by 3. What is cot equal to? It is base upon perpendicular. That means this is equals to base equals to 4 and perpendicular equals to 3. What is not known to us? Hypotenuse is not known to us. And how do we find out hypotenuse? Using Pythagoras theorem. So use Pythagoras theorem to find the value of h, and that will turn out to be 5 units. You can easily calculate this thing. What I need in the given expression, I need to use sin A, I need to use cos A, I need to use tan of A. So let us find their values one by one. Sin A equals to perpendicular upon hypotenuse, that is equals to 3 by 5. Cos A equals to base upon hypotenuse, which is going to be 4 by 5. And tan A is nothing but perpendicular upon base, which is equals to 3 by 4. If still you don't remember the values, then use the phrase some people have curly brown hair through proper brushing, or just look at the ratios that you have written in the beginning of the lecture and try to revise them so that you can remember those values and use in the questions. Since we need to verify the two expressions whether they are equal or not, we are going to start with the separate expressions. Let us start with the left hand side. It is 1 minus tan square A upon 1 plus tan square A, which is nothing but 1 minus 3 by 4 whole square upon 1 plus 3 by 4 whole square. It's just a mathematical calculation. You can solve it and the answer is going to be 7 by 25. Every step is written in a proper way, but make sure to apply and to solve the calculation part on your own and then verify your answer. So this is my left hand side, which is 7 upon 25. Let us try to find the value of right hand side. Now right hand side is nothing but cos square A minus sin square A. What is cos A? We evaluated cos A as 4 by 5. So it is 4 by 5 whole square minus 3 by 5 whole square, which is nothing but 16 minus 9 whole upon 25. That is again turned out to be 7 upon 25. So I can say that just by finding the values of left hand side and right hand side separately, we can say that the two expressions are equal to each other. So that proves the whole question at the end. Okay. Now only few more questions, and then we'll discuss the remaining set of questions in the next lecture or the next video. In triangle ABC, right angled at B. So make sure in this question it is given that it is right angled at B. If tan A is 1 by root 3, find the value of, in the first part, sin A into cos A plus cos A into sin C, and in the second part, cos A into cos C minus sin A into sin C. So if you observe the question, what do you need? You need the value of sin A. It means when I need sin A, my base angle is going to be A, and I also need the value of cos C or sin C. It means whenever you need these values, your base angle is going to be C. So again, in the given question, I've given you two different triangles, one with base angle as C, another with base angle as A. You must know when and why to use these two diagrams according to your requirement. Alright, so tan A is nothing but perpendicular upon base. That gives me that perpendicular, we can take perpendicular as 1 and base as root of 3. Alright, so this is what we are going to use to find the value of hypotenuse. So again, using Pythagoras theorem, h square equals to p square plus b square, h square equals to 1 square plus root 3 whole square, which is going to give you h square equal to 4 and h is equals to 2 units. Alright, so once you have the value of h, what do you need? You need to find all the values which you required for part 1 and part 2. I need sin A, that means sin A is equals to perpendicular upon hypotenuse. Now for sin A, which triangle we are going to use? We are going to use the triangle which has base angle as A. So this is my base angle because this lies on the base of the triangle. Alright, so sin A is perpendicular upon hypotenuse. I can put the values. Since tan A equals to 1 by root 3, so corresponding to the triangle with base angle as A, perpendicular is 1 and base is root 3. For the other triangle, since AB is root 3, AB is going to be root 3 for the other triangle also, and BC is 1, so BC is going to be 1. So length of the sides of the triangle doesn't change even if you rotate the triangle for A and C. So if according to tan A, perpendicular BC is 1 and base AB is root 3, it is going to remain same even if you change the position of A and C. So BC is still 1 and AB is still root 3. What is going to be the change? It is going to change the values of sin C and cos C accordingly to the, we are going to use the triangle. So sin A is perpendicular upon hypotenuse and we are going to use the triangle with the base angle as A. So this is BC upon AC, which is 1 by 2. And cos A is equals to base upon hypotenuse. So I can mark hypotenuse over here, which we calculated. This is 2 and 2. So cos A is equals to base upon hypotenuse. That means it is root 3 upon 2. Similarly for sin C, I want its value. So I'm going to use this triangle in which the base angle is C. Alright. So sin C is equals to perpendicular upon hypotenuse. What is perpendicular? Root 3. What is hypotenuse? 2. And cos C is equals to base upon hypotenuse. In this triangle, what is base? It is 1, and what is hypotenuse? It is 2. So it is going to be 1 upon 2. So we got the values of sin A, we got the values of cos A, we got the values of sin C as well as cos C. Now let us take the first part of the question. Now let us try to find the value of the first part. First part is sin A into cos C plus cos A into sin C. Just look at the values that you obtained. What is sin A? Sin A is 1 by 2. Cos A is again 1 by 2 plus cos A is root 3 by 2 and sin C is root 3 by 2. So 1 by 2 into 1 by 2 is 1 by 4 plus root 3 by 2 into root 3 by 2 is 3 by 4. So solving this, we are going to get 4 by 4, which is equals to 1. For the second part, I need cos A into cos C minus sin A into sin C. We substitute the values. Cos A is root 3 by 2, cos C is 1 by 2 minus sin A is 1 by 2 and sin C is root 3 by 2. So this is nothing but root 3 by 4 minus root 3 by 4, and the answer is going to be 0. So I hope the final step to solve the question is not difficult for you guys, because we simply need to substitute the values. Let us take the last question of this lecture. We'll solve the remaining set of questions or similar questions in the next lecture so that you can have a better set of understanding about the topic. In the current question, in triangle PQR, right angled at Q, PR plus QR is equals to 25 centimeter. Sum of the two lengths is given to us, and PQ is equals to 5 centimeter. Find the values of sin P, cos P and tan P. So we are going to consider the base angle as P, because what we want sin P, cos P and tan P. Just mention the data in the diagram and use Pythagoras theorem. You know that Pythagoras theorem is hypotenuse square, that is PR square, equals to PQ square plus QR square. So according to the Pythagoras theorem, this is the expression. I'm going to rewrite this expression in such a way that PR and QR can come together in a single relation. Why we are using this thing? Because PR plus QR is 24. Their sum is given to us to be 25, and we can only use it if I try to write them together in the whole or on the one side of the expression. So that's why I've taken QR square to the left hand side, and so we are going to get PR square minus QR square equals to PQ square. You know that A square minus B square is the identity which you can observe in the given expression. So using that identity, we have PR minus QR into PR plus QR, which is equals to PQ square. Substituting the values that are given to us, we know the value of PQ, which is 5 centimeters. So on the right hand side you have 5 square, and on the left hand side one of the factor or one of the bracket is PR plus QR, whose value is 25 given to us. So we are going to substitute its value. Now if you simplify this thing, right hand side is 5 square, which is 25 upon 25 is going to give you the value of PR minus QR equals to 1. And as PR plus QR is already given to you 25 from the given question, from the given data, you can solve first and second equation using any of the method, using elimination method or using substitution method, to find the value of PR and QR. In fact, I can add these two expressions and I can get 2 times PR equals to 24. I'm writing it on one side, that is going to give me PR equals to 13 centimeters. So this is PR equals to 13 centimeter or 13 units. And similarly, if I put the value of PR in one of the equation 1 or 2, I can find the value of QR equals to 12 centimeter. So once I have the value of PR, which is 13, and QR which is 12, I can find the value of sine P. What is sine P? Let us find its value. Sine P is nothing but perpendicular upon hypotenuse. So in the given triangle, what is perpendicular? It is 12. What is the hypotenuse? It is 13. I need the value of cos of P. What is cos P? It is base upon hypotenuse. So this is going to be 5 upon 13. And last is tan P, which is equals to perpendicular upon base. So what is perpendicular upon base? Perpendicular upon base is 12 upon 5. So that is the answer to the given problem. Alright. So try to revise these questions, try to solve these questions with me. Pause the lecture wherever you want and try to analyze the questions, what we are doing and how we are applying the concepts to get the values of other trigonometric ratios. That's all for today.